what I'm doing at the moment is I'm machining a pocket in the soft jaws to accept the 3/4 inch diameter of the sprocket flank, this thing here. That will sit in the vise. These are just spacers. This is a previous round hole, I've used it. All these soft jaws are really handy with these vices. When I go to clamp the sprocket in there, I'll just keep one of these spacers at the back side here, just so that the jaws don't try to squeeze too far out of parallel. It's a decent way to treat your vise. Anyway, we'll get back out when we get the sprocket in the way. Well, that's the pocket cut in the soft jaws. The standard of finish that this thing achieved is brilliant. You can probably see it there. And also, for accuracy, the diameter of this is 0.752, and I programmed that for 0.752, and you can see it just enters. So, in terms of accuracy, I think it's pretty good. Anyway, we'll proceed with cutting the thread on the counterbore. Okay, well, here we are again in the workshop. The next process is to put an internal thread on here. I've chosen 18 threads per inch, 5/8. Sorry, 3/4 inch. I will have to check all this. Yeah, 5/8, sorry. As you can see on the screen, 0.625, which is 5/8. My internal diameter is slightly larger than the minor diameter there, so I'm not going to have a very good thread, but it's only, well, having said that, it's only a few thou difference, probably about 10 thou on the diameter, which is only 5 thou on the threads, so it's not that bad. And we'll see what happens. And I'll get all the inputs put in, and we'll have a look and see what happens to the screen. Well, that's it. Program started in single block mode, and you can see the tool is X0, Y0, center of the hole. I checked that before, so we'll let it come down to, it should stop 1/8 of an inch above the top surface of the tool. So we'll see how it looks. I've got a bit of room, but I can always linger by the stop button or slide the max fill over towards zero travel, just like that if I wanted to. Looking at that, we've got 1.7 inches to run, 1.4, about an inch, so it's looking pretty good. In fact, I'm pretty certain that's going to be it. 0.3 of an inch. There we are, and that is sitting about 1/8 of an inch above the top of the work. I'm not too fussed. It's not too, it doesn't have to be too accurate on depth, this one. Okay, well, I think we'll try. It's not really worth going single block for this one anymore, so we'll do the business. And there we go. Yeah, it's looking okay. Got a long way to go. I'll increase the speed. If you come over to the screen here, you can see distance to go. There's no, there is distance to go. In the Z-axis, 0.4546 of an inch, so it's got a long way to go, and I think there are 7 passes in all, maybe more even. And as you can see, there's the tool path on the screen, and so far it's as I suspect. It's not actually cutting, but my minor diameter is too large. not by much. I'll probably do 2 cuts or so before it actually cuts any thread at all. Not to worry. Okay, well we'll come back to it when it's cutting. Well, switch the coolant off so we can see whether this is going to take a bite on this thread this time around. It's taking more passes than I thought to actually take up, but I don't think it's actually cutting yet. It's just entering the top of the bore, the counter bore now. So we're on the penultimate pass. I just thought I'd put the screen on isometric view. And there you go. You can see the kind of looks strange that. It looks as though the tool is going around the outside of the work, but it's not. It's going around the inside, as you can see. Not shifting view. The thread's looking very good from what I can tell. As I see, it's got one more pass and we'll. Well, the machine's got about another 1/8 of an inch of threading to do. A couple of more revolutions around the inside of the work, and we should be able to see what the thread looks like. Hopefully it'll be a really good finish. It's not any specification, it's just 26 threads per inch. I'm going to have to make a special bolt to suit the extractor can screw into there. An extractor bolt, basically. Drive down on that thread and push against the end of the shaft of the magneto and drive it off the shaft. And when it's required. So we've got about a half a turn to go. Another revolution. 45 thou. There we go. When I get round to about that position, on the next revolution, it will finish. About here. Right, let's take a look at this. And we can see it looks pretty good. That's a lovely clean thread in there. You can see the light reflecting off it. It is a really good clean thread. In fact, you can put your finger in there and you can feel how smooth that thread is. Better than most threads I can produce on the lathe. I'm not that good at screw cutting on the lathe. Anyway, next process, I'm going to have to take some metal off the flange here. I should have thinned it down a bit more. There's 2 ways I could do it. I could cheat with the Sprocket cutting program and cut, make a few passes and just drop the tool down a little more than it's programmed. But I think I'll just take the facing cut off here with one of the end mills or one of the mills, and then run the Sprocket cutting program.